In this video we will look at double angles. Before we get started, as normal, just to run through how we do mathematics. Now number and copy the examples. Ask your teacher if there are any steps that you do not understand. Number the questions. Unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Mark your answers if it is incorrect, write down the correction, and make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. So to start off with, we look at the double angle identities formulas, and these are good if you know them off by heart. So if I have sine 2 theta, the only identity is equal to 2 sine theta cos theta. But if I have cos 2 theta, I can either change it into cos squared theta minus sine squared theta, or 2 cos squared theta minus 1, or 1 minus sine squared theta. Now if I do identities and I have to replace, if I see cos 2 theta and I have to replace it, I can either replace it with either one of these three, and normally I have to look at the sum to determine which one you're going to use. And sometimes you have to try one and see if it works and then try another one. But we'll look at the examples now. So what we're going to do in this video is we're going to start by evaluating expressions using special angles. Then look at the quadrants where we use cos diagram, and then identities, and then trigonometric equations, and all these including double angles. So if we're going to start with evaluating, the first example, example 27, says evaluate the following expression without the use of a calculator. So if I have cos squared 15 minus sine squared 15. So if I know my double angle formulas off by heart, I know that cos 2 theta is also equal to cos squared theta minus sine squared theta. So then I would be able to recognize this expression. Now if I treat 15 as theta and just replace it, now I see this is then equal to cos 2 times 15, where in place of theta we now have 15, and this is then equal to cos 30 degrees, whereas 30 is a special angle, so I can calculate that without the use of my calculator. I can just say, I'll draw the 30-60 triangle, where this is 1, 2, and 3, and for cos we have adjacent over hypotenuse. So from the 30-degree angle, I've got the adjacent over the hypotenuse gives me square root of 3 over 2. Right, for question 27.1, now if we want to evaluate the following, here we see this is 2 cos 22,5 and sine 22,5. Now we know that sine 2 theta is equal to 2 sine theta cos theta, or even cos theta sine theta, that's the same thing. Now immediately recognizing this, and once again we use or we replace theta with 22,5, then this expression will be equal to sine 22 times by 22,5, and then this is equal to sine 45 degrees, whereas 45 is also a special angle, and I draw my 45-degree triangle where these sides are 1, 1, and square root of 2. So for sine we have opposite over hypotenuse, so from the 45-degree angle, opposite is 1 over hypotenuse square root of 2, so this is 1 over 2. Now just to finalize the answer, we write it as, in rationalizing the denominator, this will then be equal to 2, or square root of 2 over 2. So those were examples of evaluating, and now we look at quadrants using the cos diagram. For example 28, it says that if tan theta is 4 over 3, and the restrictions are 90 degrees is less than or equal to theta, and theta is less than or equal to 360 degrees, we evaluate for A, sine 2 theta, cos 2 theta, and tan 2 theta. Now, if we're given these two pieces of information, the first thing we can do is to draw the our cast diagrams where we are given that tan is positive, because this value is positive, and we have to draw it in these restrictions. So for tan to be positive, if I just do that here, for tan to be positive, it's either in the first quadrant or in the third quadrant. And then for it to fall in this this region, it's from 90 up to 360, so it can be either these three quadrants. And we see that both of them are applicable in the third quadrant. So we're going to draw our sketch in the third quadrant. And then for tan, so theta goes all the way over here, but we're going to work as if we're working out of this angle. So if tan is opposite over adjacent, then opposite is 4 and adjacent is 3. But we have to be careful with our sign, since this is the negative x on the coordinate plane. This is negative 3 and this is negative 4, because this is the negative y values. Okay, and then just to find out, to calculate this length over here, we use Pythagoras. So r squared is equal to negative 3 squared plus negative 4 squared. So r is equal to the square root of 9 plus 16, and that's going to be 25, so r is equal to 5. Okay, so now we're in a position to start to evaluate these guys. So if I start with A, which is sine 2 theta, the first thing I'm going to do is to expand it. So then I have 2 sine theta cos theta. So now I can just use my triangle to find, to calculate the values for sine theta and cos theta and substitute them in. So for sine theta, we have opposite over hypotenuse. So this is going to be negative 4 over 5. For cos theta, I have adjacent over hypotenuse. So that's negative 3 over 5. And then I can just put that in the calculator and calculate that. So if we say 2 times by negative 4 over 5 times by negative 3 over 5. Then we get 24 over 25. Okay, so now moving on to B. B is equal to cos 2 theta. Now, this one we can pick which one we want to use. So I'm just going to go ahead and use 2 cos squared theta minus 1. Because I know what cos's value is, we can just substitute it in. So 2, and then instead of cos theta, we saw cos theta is negative 3 over 5, but now we have cos squared theta, so we have to square that value that we substituted in for cos, minus 1. And once again, I can just put this into the calculator. I'm just going to do it here. So I have 2 times by negative 3 over 5 and that's all squared minus 1. So negative 7 over 25. And then finally for C, we need to calculate tan 2 theta. Alright, now the formula for tan 2 theta is not in your, it's not in the high school syllabus. So what we're going to do is we're going to remember the identity that says tan theta is equal to sine theta over cos theta. So we're going to write tan 2 theta is equal to sine 2 theta over cos 2 theta. And then we replace our values that we just found for these two. So for sine 2 theta we had 24 over 25, and for cos theta we had negative 7 over 25. Now, the steps are pretty easy to simplify this. We just say this divided by that. If I just do it here, if I say 24 over 25 divided by the bottom fraction, negative 7 over 25, then this division becomes times. So this is then 24 over 25 times by, and I swap these two around, 25 over negative 7. I can cancel these two, and then I'm left with this 24 over negative 7. So for question 28.1, here we're given that 7 sine theta plus 3 is equal to 0. And we have this restriction. Find the values of, again, sine 2 theta, cos 2 theta, and tan 2 theta. So first of all, let's just solve for that. We've got 7 sine theta plus 3 equals to 0. And to solve for it, I just want to isolate the sine theta, taking the 3 over to the other side. 7 sine theta is equal to negative 3, and then dividing both sides by 7. I have sine theta is equal to negative 3 over 7. Alright, so now we can draw our cos diagram, and just to determine in which quadrant we're going to be working. For sine to be negative, it's either going to be in the third or the fourth quadrant. And then for these restrictions from 90 to 270 is either in the second or the third quadrant. So meaning both are applicable in the third quadrant, meaning we're going to work in the third quadrant. Okay, so for sine, opposite over hypotenuse, if this is our angle, we're working out of this angle, opposite negative 3 over hypotenuse, which is 7. And then we use Pythagoras to find our x value. So x is equal to the long side, the hypotenuse side, 7, or x squared is equal to 7 squared minus the other short side squared. So x is equal to 49 minus 9. So this is the square root of 40. So this will then be equal to 40, square root of 40. Although since this is in the negative, this is negative 40. Alright, so now we can go ahead. If I have sine 2 theta, so let's start with A, sine 2 theta. All that I have to do now is to break it up into 2 sine theta cos theta. Then I can replace it with its respective value. So for sine theta, we're given. So that one we're just going to substitute in here. So minus 3 over 7. And for cos, we've got adjacent over hypotenuse. So that's negative square root of 40 over 7. And then we can just substitute this into the calculator. Right. So here we have 2 times negative 3 over 7 times by negative 40 square root of 40 over 7. Okay, so this gives us 12 square root of 10 over 49. 12 square root of 10 over 49. Okay. Now moving on to sine 2 theta. Here, cos 2 theta. Here we can replace it with either one of its identities. They all will give us the same answer. So I'm just going to replace it with cos 2 theta minus sine 2 theta. And if I have cos squared, just remember that it's cos squared theta. You can write as cos theta squared. This is actually what it's saying, but this is your maths notation. So whenever you have to substitute in the value for cos squared theta, substitute it inside here and square the value. So here we have cos's value we've got as negative 40 over square root of 40 over 7. and sine squared minus sine is negative 3 over 7 all squared. And that we can also just put on the calculator as bracket negative 40 square root of 40 over 7, and that's all squared, minus bracket negative 3 over 7 all squared. So that's 31 over 49. Right. Now, finally for tan. So tan 2 theta. And once again, we're just going to replace it with sine 2 theta over cos 2 theta. And these values we've just determined, so I can just substitute in the value for sine 2 theta as 12 square root of 10 over 49. And that's over cos 2 theta, which is 31 over 49. Now to calculate that, I can just put it in the calculator, but it's real easy. If I have a fraction over fraction 12 square root of 10 over 49, then divide it by the denominator, 31 over 49. This division changes to a multiplication sign and swapping the denominator and the numerator around. So this is then times by 49 over 31. These guys cancel, and my final answer is 12 square root of 10 over 31. The quadrants, and then next we look at identities. So prove the following identity. Now, of course, we're going to start with the left-hand side since that's the most complicated one. And I'm going to start by saying left-hand side is equal to sine x plus sine 2x over 1 plus cos x plus cos 2x. All right, so first of all, we have these double angles here, so we have to replace them with their respective identities. And for sine 2x, it's quite easy because there's only one to replace with, so we immediately know what we need to replace it with. We need to replace with 2 sine x cos x, and then we go down to cos 2x. Now this one we need to think about a little. What will be best to replace cos 2x? Now if I look at this, we only have cos here at the bottom, so I'm going to start and try to replace it with the identity that only contains cos. So I'm going to replace it with 2 cos squared x minus 1. Yes. All right, so let's now factorize, because we can see that we can take out a sine x here and here, and then we can also factor out a cos x over here. Now, if I take out sine x, I'm left with, for this term, 1 plus, and this term, 2 cos x. And at the bottom, this 1 and this 1 will become 0, equal 0. Then for these two remaining terms, there's a cos x that I can take out as well. So if I take out cos x, then for this term remaining, it's just 1, a placeholder 1, plus this 2 remains, and there's another cos x there that remains. Alright, so now these two can cancel out, they are identical. Sine x over cos x is equal to tan x, and that is equal to our right hand side. Right, now question 29.1. So we prove the following. Now once again we're going to start out with the left hand side, and we first state that the left hand side is equal to 1 minus sine 2x over sine x minus cos x. Right, so now we can immediately see we can replace this guy. So 1 minus 2 sine x cos x over sine x minus cos x. Right. Now this looks like a dead end, except if we think about this 1, we know that sine squared x plus cos squared x is equal to 1. And another thing that I know, if I see sine x and cos x together, I know that this x squared plus xy plus y squared, if I factorize that, it gives me x plus, or this actually 2 there, x plus y squared, but that's just that comes by using these a lot. So I can actually already kind of see what's going to happen if I replace 1 with this, and sine represents x and cos represents y. It looks like we already have that middle term as well. Alright, and this sine x minus cos x kind of represents this. So let's see if we replace this 1. But when I replace it, I'm going to put my sine squared x in front of this term, and my cos squared x at the back of that term. So it's going to be sine squared x minus 2 sine x cos x, and then plus cos squared x, right, over sine x cos minus cos x. Now that I have these 3 terms, and they resemble this more or less, I'm going to factorize this. Now, in our case, we just have a negative here. So if we replace this with a negative, what happens is if I factor it, it's this is just a negative. Because if I really want to, if you go through the factors of 1, it's just 1 times 1, and to get if I just write it down here, to get negative 2, we say x minus 1, x minus 1. That's if we have x squared minus 2x plus 1. That's how it would factor. But now that we have this y over here, we have a y here and here, and this is now just represented by sine x and cos x. So factorizing this top part, we have sine x minus cos x and sine x minus cos x all over sine x minus cos x. Alright, so now this means that one of these at the top can cancel with the bottom one, and all that's left is then sine x minus cos x, and this then is equal to the right hand side. So for example 30, prove the following identity. Okay, so over here we have both sides looking pretty complicated, and even both sides have a double angle that's in it. So we might have to start from both sides at some point and work our way to a common point. Now let's look at starting with this guy. If I have my left hand side equal to cos 2x over cos x plus sine x, and that's cubed. So what will I change this guy into? Let's change it into the one that, since we've got a cos x and a sine x over here, let's change it into the one that contains both. So if I change it into cos squared x minus sine squared x over cos x plus sine x. Now what can I do next? If I look at this top part, I can actually factorize that. That looks like difference of squares. If I have x squared minus y squared, difference of squares says x plus y, x minus y. Okay, so now I'm going to say cos x plus sine x and cos x minus sine x. And that's all over cos x plus sine x to the power of 3. Now, this factor over here is identical to these, and I'm going to cancel that one with one of these, so there's just a square left. And then what can we do? So we already see that our right hand side already contains this part over here. We just now need to get this bottom part in a way to look like this one's denominator. Alright, so I'm going to write now my simplified form, cos x minus sine x. And what I'm going to do is I'm actually going to square this out. So you can, I know mostly people like to expand it, plus sine x, and then cos x plus sine x. That's if you have these, that's the same as writing it as square and then FOIL it out. I'm just going to quickly multiply it out with a quick way where I square the first term, so that becomes cos squared x. Multiply them together and multiply by 2, so that's plus 2 cos x sine x, and then square the last one, plus sine x. But if you decide to expand it first and then FOIL it out, you'll get to exactly the same answer. Okay, so now I can see this part over here resembles the double angle formula for the sine 2x, and then cos squared x plus sine, this must be squared, sine squared x is equal to 1. So I can now say I've got cos x minus sine x, and then at the bottom this cos squared x plus sine squared x is equal to 1, and this 2 cos x sine x is equal to sine 2x, and then I have my right hand side. Okay, so the question 30.1 says prove the following identity. Now here we have, I guess we're going to start with the left hand side since we see there's double angles in both of them. So if we start off with that, we get left hand side is equal to cos 2b plus cos b over sine 2b minus sine b. Okay, now the first thing we need to decide here is which one we're going to replace it with, and since we only have a cos here, I'm going to start and try and replace it with the one that only contains cos. So I'm going to replace it with 2 cos squared b plus minus 1, that one's identity, plus cos b. And then over here, we're obviously going to replace it with 2 sine b cos b minus sine b. Alright, now let's see if we can factorize some of these things. If I rearrange this one to be in the form, let's say we had 2, let's replace cos b just with x for a moment, 2x squared plus x minus 1. We have just swapped these two terms around, and I factorize that, then I get I've got 2 and 1 here and 1 and 1 here, and I want to get plus 1, so 1 times 1 is 1, 2 times 1 is 2. To get plus 1, I say plus 2 minus 1, so a plus goes over here and a minus there. So this then is 2x minus 1 and x plus 1. So if I should factorize that, I'll get 2 cos b minus 1 and cos b plus 1. Right, and then to factorize this is quite simple. We just take out a common factor of sine b that comes out, and what is left is 2 cos b for the first term minus 1 for the second term, which means we can now cancel these factors that are identical, and we are left with cos b plus 1 over sine b, and this is then equal to the right hand side. So prove the following identity. we have cos 4 theta is equal to 1 minus 8 sine squared theta plus 8 sine to the power of 4 theta. Alright, so what we can do is we can basically just start by expanding this one. So left hand side is equal to cos 4 theta. Now expanding it, we need to decide which identity to use, and since we see on this right hand side we only have sines, I'm going to use the sine formula. So this is going to be equal to 1 minus 2 sine 2 theta, right? Sine squared 2 theta, because we half the angle if we use the double angle identity. Alright, now we need to change this one, and we can now say that this one, we just replace that with a 2 sine theta cos theta. So this is then 1 minus 2. So this is 2 sine theta cos theta. So this is all squared. So you see I've replaced my double angle with its identity, but it is squared. So I have a square on the outside. Now just to simplify that, I can't take this 2 in yet. I first have to square all of these terms. So 1 minus 2, 4 sine squared theta cos squared theta, because this 2 goes to each and every base. Okay, then I can take the 2 in. So doing that, we have 1 minus 8, if I multiply these two together, sine squared theta cos squared theta. Okay, so now we have a problem. We have a cos over here, and our final answer shouldn't have a cos. So, but we can replace cos, because we know that sine squared theta plus cos squared theta is equal to 1, which means if I want to replace cos squared theta or solve for cos squared theta, I just take the sine over, then I have 1 minus sine squared theta. So I can replace this cos squared theta. I'm going to say this is 1 minus 8 sine squared theta, and then in brackets we've got 1 minus sine squared theta. Right, now to see, this is in front of our bracket, so we can multiply this factors into the bracket to both of those terms. So 1 minus 8 sine squared theta, and then if I take this one in, the minus and the minus becomes a plus, the 8 goes in front, and then sine squared times by sine squared becomes sine to the power of 4 theta. And there we have our desired results. We've got it equal to the right hand side. Right, for question 31.1, here we have also now a sine 4 theta. So like we did with the previous one, we're just going to keep expanding our left hand side, which is equal to sine 4 theta. So expanding that, we don't have to choose which one. We know this has to be 2 sine 2 theta and then cos 2 theta. All right, so expanding it even more, this 2 theta now, sine 2 theta is easy. That's just 2 sine theta cos theta. And then for cos 2 theta, we have to decide which one we want to use. Now, if I look at this, there's actually sines and cosines there. So this one's not going to be as easy to decide. So let's say we're going to use, we use sine. Let's use sine. So the reason I said sine, because I see more sines there than there is a cos. So let's say we say this is 1 minus 2 sine squared theta. Okay, and if it doesn't work out, we can just go back and replace it with something else. Alright, so now all that's left now is just to multiply everything out. let's start by multiplying this 2 in over here. Then we have 4 sine theta cos theta, 1 minus 2 sine squared theta, and then we multiply in this these factors that's in front of the bracket. So going to both of these terms, the first one is just multiplied by 1, so it remains 4 sine theta cos theta. Then taking it to the second term, the 4 times the 2 becomes an 8. This sine times that sine is sine cubed theta, and then we have that cos theta over there. Alright, so this actually looks identical. Then we have replaced it with the right one. So this then is equal to the right hand side. Okay, so that was the identities. We now move on to the trigonometric equations. Now, the first example, find the general solution of the following equation. If we look at this, it looks quite daunting, but the first thing I see is I've got my 2 cos 2 theta and sine 2 theta over here. And what I'm going to do is just to replace it. Now, remember with identities, our aim was always to get the same identity, right? Now, what I'm going to do is we need to decide now which one to replace cos 2 theta with. And this one is 3. So we could replace it with the cos theta, but this one's going to produce a cos and a sine. So let's replace it with the cos and the sine. So we've got cos squared theta minus sine squared theta minus 2 sine theta cos theta, and then minus 1 equals to 0. Okay, so here we'll have 3 cos squared theta minus sine squared theta, or 3 sine squared theta, minus 2 sine theta cos theta. And this 1, because we have 3 over here, I don't think that if we should factorize all of this, can we factor, let's say we replace it with x and y, then it would look something like this. We would have 3 x squared minus 2xy and then minus 3y squared. That's how, just to see if I can factor this, replacing the sine and the cos with x and y. Alright, so, and then this 1 would go over to the other side. But now, if I factor this, I've got 3 and 1 and 1 and 3, and then also 3 and 1, and I want to get negative 2. So if I say 3 times 3 is 9, and 1 times 1 is 1, so that can't get me negative 2. And also if I say 3 times 1 is 3, and 3 times 1 is 3, this is also not going to give me negative 2. So that one won't factorize, so that there's something still wrong with this one. Now if I look at this 1, instead of maybe taking it over, there is another option we can try, and that is to change the 1 into sine squared theta plus cos squared theta, and see if we can, what we can do with that. So this is going to be sine squared theta plus cos squared theta equal to 0. Now this is then still the 3 cos squared theta minus 3 sine squared theta minus 2 sine theta cos theta minus sine squared theta minus cos squared theta. And now we can add these two to these, like these two are the same terms, and these two are the same terms, the cos squared. So that means we will now have minus 4 sine squared theta, and over here we will have, let's put this one then next, the minus 2 sine theta cos theta, and then for this cos and 3, so this is plus 3, and that's, so 3 minus 1 gives me plus 2 cos squared theta equal to 1, equal to 0. And at this point we can actually divide everything with a negative 2 to simplify this, because this equation we can just divide both sides as long as we divide with the same thing. So I'm going to divide by negative 2, which will make this equal to 2 sine squared theta. This is just plus sine theta cos theta, because I've just divided it by negative 2. Divide this by negative 2 becomes negative cos squared theta equal to 0. 0 divided by negative 2 is still 0. Okay, now let's see if we can factorize that. If I replace it again with x and y, I've got 2x squared plus xy minus y. So if I factorize that, I've got 2 and 1 on this side and 1 and 1 on this side, so I need plus 1. 2 times 1 is 2, 1 times 1 is 1. To get plus 1, I say plus 2 minus 1. Minus goes there and the plus goes there. So this will then be 2x minus y and x plus y. So in terms of sine theta and cos theta, we will have 2 sine theta minus cos theta. And for this side, we'll have sine theta plus cos theta equal to 0. Alright, now we are finally at the stage where we can go ahead and solve for this. We can now say 2 sine theta minus cos theta equals to 0, or sine theta plus cos theta equal to 0. And this looks wrong because we've got two different identities, but we can change it into one. And how we're going to do that is by taking this cos over to the other side. So we have 2 sine theta equals to cos theta. Then divide both sides by cos theta. So this is 2 sine theta over cos theta equal to, if I divide cos theta by cos theta, it's equal to 1. Then this expression becomes tan theta. So tan theta, if I divide both sides by 2 as well, tan theta is equal to a half. And now we can go ahead and use QRS to solve for that side of the equation. So for tan, in the quadrants, for tan, tan is positive in the first and the third quadrant. Then for the reference angle, we use the calculator. We just say the inverse of tan. So shift tan 0.5, and that gives us 26.57. So 26.57 degrees. That's our reference angle, and then finally we solve. So for the first quadrant, we just have our reference angle. So this is then theta is equal to 26.57 degrees plus the 180. Because we're working with tan, it's 180k. And then for the second quadrant, theta is equal to 180, or actually third quadrant, it's 180 plus. So theta is equal to 180 plus 26.57 plus 180k. But now these two solutions are going to be identical. So in actual fact, we don't need, because if I replace k, if I replace 1 for k, I'll get to the same answer with this one. So this general solution is not necessary because it's identical to the top one. So this is then our final general solution for the one side of the equation. Now on the other side, we can also change this into tan by saying sine theta equals to negative cos theta. If we take that over, then divide both sides by cos theta. So then we have sine theta over cos theta equals to negative 1. Alright, now for the it's first just to say tan theta equals then to negative 1. Then we start by QRS, and the quadrants where tan is negative is in the second and in the fourth quadrant. Then our reference angle is where we say shift tan just 1. The negative was taken into consideration with the quadrant, so that's our reference angle 45 degrees. And then to solve for the second quadrant, we'll have 180 minus, so theta is equal to 180 minus my reference angle plus 180k. Right, then theta is equal to 180 minus 45, so that's 135 degrees plus 180k. Alright, and then if we do the fourth quadrant, the same will apply. We'd still get the same general solution, just with different k values. So these are our two final general solutions for this sum. So now for question 32.1, we need to solve for the following, and this is the specific solution where we need to solve for values that's in these regions now, or between 0 degrees and 360 degrees. So the first thing we have is we've got 1 plus sine theta, square root of that, equals to cos theta. Alright, now the first thing I see is I see a square root, so therefore I'm going to square both sides to get rid of it. And if I do that, the squaring both sides, then I'm left with 1 plus sine theta equal to cos squared theta. So now that we have this, we need to try and find a way of getting one trig identity. Now we know that we can change cos squared theta into sine squared theta. But before we do that, let's just take it over to the other side. We have 1 plus sine theta minus cos squared theta equals to 0. Then cos squared theta, or cos squared theta plus sine squared theta is equal to 1. So take the sine squared over. So then cos squared theta, if I have 1 plus sine theta minus, then cos squared theta becomes 1 minus sine squared theta from this identity equal to 0. And then just to simplify that, we multiply the bracket out. So we have 1 plus sine theta minus 1 plus sine squared theta equal to 0. And then this 1 and this minus 1 becomes 0. And we are left with, if I just rearrange this, we are left with sine squared theta plus sine theta equal to 0. Then if I factor out sine theta, I'm left with sine theta plus 1 equal to 0. Then I can say sine theta equals to 0, or sine theta plus 1 equals to 0. So here we can just use our graph, our sine graph, to determine what values will equal to 0. So here we have the sine graph looking like this, and it goes up to 360 where this is 180, and it goes up to 1 and down to negative 1. So it starts with 0 where sine theta is 0 at 0 degrees, so that's 0, and then every 180 degrees it's 0 again. So to simplify this, theta is just equal to 180k. If we move on to the other side, we have sine theta equal to minus 1. Now, where is this graph minus 1? It's minus 1. This is 90 degrees at 1, and at 270 degrees it's at minus 1. Now, we say that theta is equal to 270 degrees, but now every 360 degrees it's going to reach minus 1 again. So my period that I put in there is plus 360. Okay, and these are my two general solutions. Now to find the specific solutions that fall between these two values, I can substitute in values for k. So if I say theta, let's just say it here at the bottom, theta is equal to, and then list our values over here. If I say 0, for k, I get 0, but 0 is excluded because this is a round bracket, so 0 doesn't fall in this. If I say 1 for k, if I say theta is equal to 180 and replace 1 with k, then I get 180, which does fall here in between these two values. So this is then 180 is one of my solutions. Then if I move on further on, if I put 2 instead of k, I get 360, but 360 is excluded, so that's not a solution. If I move over to this side, because if I put 3 in for k, then it's going to go way over. Now if I move to this side, if I put 0 in place of k, my answer is just going to be 270. So 270 falls between these two restrictions, so that's a solution. And then if I put 1 in place of k, it's going to go way over the restrictions, 270 degrees plus 360. So these are then my two specific solutions. That was the equations, and then we're done with this video.